Hey guys, this is the first lesson of 2.1 and we're going to be working on using graphs to relate to quantities. So when we look here at this beginning question, we want to match up. Just take a second to think which graph matches with which of these containers. If you haven't, pause this for a moment and think about it. So here's the answer. Your first graph actually goes with the third container because as the height up here increases, it doesn't need as much height to increase the volume. So that's why your height slows down and your volume speeds up, because the volume is going quicker than, like, your change in x is going faster than your change in y. So then our second graph here, do you think it goes to the first or the second? We can assume the first, because without knowing the circumference or the radius or anything, we don't know which has a greater volume, but we could assume the taller vessel probably is going to have the greater volume, so that would leave the third going to there. So moving on, when we look here at this graph right here that shows you blowing up a balloon until it pops. So you see that we don't have a constant rate of change because you're blowing it up like with your mouth. So if you had a tank, this might be different. But the variables here, the two things that change, are the time and the volume. So the volume does what each time you blow? It increases. And when the balloon pops in the middle of the fourth blow, the volume does what? Now here's a place where I like to get all like kind of nerdy and say instantaneously drops to zero or something like that. So there you go, instantly drops to zero. Alright, so take a moment then. What two variables in this graph are there? What two things change in the graph? And hopefully you thought of length and time, because those are the two things that differ as we go through the graph. So now we look at matching a table to the correct graph. So what we see here is video download. So a band allowed fans to download videos, and on day 1, 2, 3, and 4, everything was tracked. So if we look at the data, how they followed it, as the days increase or progress, you want to look at what happens to the downloads. Well, they are also increasing or progressing. So we know it's going to be one of these graphs with the upward slope. Really, we can, from there, get rid of the fourth graph, D. Sorry about that. So, with graph D out of the picture, we have to then decide, how do we figure out which graph is correct? Well, here we see a steeper increase in downloads compared to day. Here everything is very consistent, very uniform, and very proportional. And here the downloads kind of start to taper off or slow down. So let's look over here at the differences between everything. So do a little bit of math and figure out what the change in the downloads are. So what we can see here when we look at the change between day 1 to 2, 2 to 3, and 3 to 4 is the changes keep getting bigger. So the gap in the downloads is going to keep getting more dramatic. So that means that graph B is going to be our correct graph, because the jumps in number of downloads keeps getting bigger and bigger and bigger. So take a second and look at this data table and decide which graph would accurately represent the data in the table. Alright, so when you analyze this data table, what you should see is that the y change is always 2/10 for every time that the x changes 1. So what that actually represents for us is a proportional relationship between the x and the y. Well, actually not proportional, because it does not go through the 0, 0 point, but it is a constant change. It's downward, so either it's going to be A or C, and you have to decide if you think C is actually linear or if you think A is. Now, since we progressed 3 days and we're still at 4.4, I would go with C, because it looks like if that's 5, that could be 4.8, 4.6, 4.4, and work its way down to 0. Alright, so now we want to try to draw our own graph. So what we're going to model is a model rocket as it rises quickly from the launch, slows to a stop as its fuel burns out, begins to fall quickly until the parachute opens, after which it falls slowly back to Earth. So you need to label the x and y variables and decide what those would be, and then try to draw a graph for this. So pause the video and take a moment to draw this graph. Alright, so hopefully you have something like this where it's rising quickly, almost at a constant rate, probably could be at a constant rate until it starts to lose its fuel. So right here it probably starts to run out of fuel, it slows down, slows down. There's a point where it actually probably does not change height at all. That would be that point right there, which is where it then changes direction and starts to come down. It'll start down very slowly and then speed up. And then as the rocket realizes that it's falling, the chute will pop out, and then it will slow the fall down to the earth. I could have probably made my fall down to the earth even slower, maybe a slope kind of like that. But hopefully, you know, this is what went through your head. Alright, so suppose you are swinging on a playground swing, and don't even try to lie, everybody loves swinging on swings. So here we have two graphs, either of which could represent your time on the swing. So here what we see is that the y-axis is representing distance from the ground, so that this one, you keep coming back to that same point. Here, as time progresses, you get higher and higher and higher. Here's supposed to be where you're swinging the highest, and then you get lower and lower as you stop swinging. So which of these graphs would accurately represent you actually swinging on the playground? Hopefully you're thinking A, because when we keep coming back to the same distance from the ground, well, you know how a swing works. You have a point up top, and you are essentially on the circumference of a circle. That's a very bad drawing, but you know what I mean. You keep coming back to the same height over and over again, and when you swing the highest, you are the furthest away from the ground, but you still come back to this point, you know, probably about 18 inches to 2 feet off the ground. Alright, that is all I really have for 2.1, so make sure you download the homework and do the practice. You can do some work on the online modules if you'd like, but please, again, as always, let me know if you have any issues or trouble. Contact me in some way, let me know so I can help you out. Thank you very much.